Hello, welcome to Symbolic Logic. Recording a video for y'all covering some of the homework solutions for homework 9. I know it's a little tricky, partly tricky because Microsoft Forms doesn't allow for multiple answers. And I'm asking you for giving me all these that are true. So what I'm going to do instead, we've talked about that. If you got one of them right, I'm going to give you credit. But what I'm going to do instead, just so you understand why the answers are correct that are correct and why the answers are incorrect that are. So I'm just going to walk through in careful detail some of those answers here. So for the first one, we've got a domain, as we always have when we're dealing with interpretations. And what is it? All the things, all of them. Then we also have an extension. Hopefully you can see this. Is that coming through clearly? Try a couple of different markers just to make sure the extension we have, among other things, that's not going to work. Boom, there we go. P with an arity of 1 is a parrot. And then let me make that. Extensions, and then domain. We also have R arity of 2. This just means is related. And we also have T arity of 2 is taller than. And then the last, I believe, is a lamp. So there's our extent of individuals. We have A. This is for Alex, lowercase a, lowercase b, Bob, and then we have lowercase c, that's Charles. Okay, here's our setup for the case as a parrot is related to whatnot. We also have some facts here we want to put on the table, among other things. So Alex is a parrot that is taller than Bob. A parrot that is taller than Bob. We also have that Bob is a lamp. Charles is a lamp as well. That is taller than Bob. These interpretation facts about our domain. So what we're trying to do now is determine if there are other facts that are true about the domain. So I've asked you in the first question, as a matter of fact, I've asked you 4 options, like which of these 4 expressions are true. What I'm going to do now is, given this setup, walk you through how to answer those questions. Now, I'm going to go ahead and erase this. So you take a picture. Make sure you got it. Hopefully you're writing this down with me. If not, too bad. Go back to the video. But let's check the first thing out. So the first one I asked, for all x, for all y, everything is taller than everything else, or everything is taller than everything else, or everything is related to everything else, or everything is taller than everything else, or everything is taller than or related to everything else. So note, what I've done here is I've flipped around the quantifiers, or I'm sorry, the variables, but note that the quantifiers are wide open, right? The universal here, unrestricted. So this whatever goes in for x here could be the exact same thing that goes into y throughout. Right? There's no restriction here. So this is important. You can kind of eyeball this, I think, and determine whether any of the disjunctions or disjuncts in the disjunction are true. Remember, disjunction, the truth rules for this, or the assignment rules for this, is that if any of the disjuncts are true, then the whole expression is true. So we just have to find one case where these are true. Now, I will also note that because these quantifiers are wide open, because they're not restricted. X could be Y, Y could be X, it could be anything. And just because I flip these around here doesn't mean you have to evaluate them. I mean, they're essentially saying the same thing as these expressions here. So you kind of only need to check one of these, right? If, for example, this is true, then this is going to be true. If this is true, then this is going to be true. So same for false. If one's false, the other's false. So really you just need to check one of these like sub-disjuncts. So I can tell you now, to make this true, you're going to need it to be the case that everything is taller than everything else, like everything. So among other things, that means, say, that Alex is taller than Alex. Now, of course, it is not true in our domain that Alex is taller than Alex, and so that's not going to be true. Let's see this in a little more detail, though, spelling it out using our favorite way of doing so, domain expansion, or quantifier elimination, as it's sometimes called, in a finite domain. The domain here being A, B, and C. What do? Well, step one. In this case, we drop off the universal quantifier. That results in, for all y, t. So now we get to the part where we have to start doing some instantiation. We're going to have to replace the x's with expressions that have a in them, b in them, and c in them. So what do? Well, we have t taller than Alex, and then everything. Also going to have to do that over here, related to Alex, everything, right? Now, we'll do that again, or, because we're going to have to spell the whole thing out, ty, so everything is taller than Alex, or everything is related to Alex, and this is the first step of the first portion for A of our expansion. Because it's universal, draw the conjunction there, and I have to do it again, this time for B. So B is taller than everything, or B is related to everything, or everything is taller than B, or everything is related to B. And the same for C. Now, we've got this complicated expression, right? We still have one universal quantifier here. We've basically instantiated in this finite domain that first, for all x, universal quantifier, so that we can get rid of it, because now we're just saying, listen, you said it held for everything in the domain, everything that had an x here, and now what we've done is we plugged in everything in the domain and bundled it up in a giant conjunction. Okay, that's essentially, in this finite domain with only three things, what the universal quantifier means. There's nothing else it could mean. So that's only one of the quantifiers, though. We've got the other universal quantifier. Now, following along this route, what we have to do is drop off that universal quantifier and then replace the y's in each case with A, B, and C. Okay, so here's what I'm going to do now. I'm going to drop this off, call this step 2, and I'm going to just kind of wipe this away and start over, because I need to expand within the scope of this quantifier. So I'll need to kind of give myself a little room. This thing's going to be long. Hopefully you guys don't mind watching me write, because it's going to take a minute. All right, what do? First we instantiate to A. All right, and we're going to have to do that similar. We're first going to instantiate to A, and we're going to have to do that again for the whole expression. So we've got TAA or RAA or TAA or RAA. All right, so we just kind of expanded again the y's inside that universal quantification scope, brought them out, and we're doing that. We're going to have to do this with b's. We're going to have to do this with c as well. This is just one. Now this was conjunction. And now what we're going to have to do is introduce TAB. So again, we're going into that y space, or RAB, that y space, or, so you can see this, TBA or RBA. Now, and to continue on and do the C's. So what does it look like over here? TAC or RAC. Thought I was going to have enough room. TCA or RCA. Now all of this is just the A instantiation. Okay? So all of that, take a magic voyage with me, look at that beautiful nonsense. Conjunction. That's just instantiation for the A within the scope of that Y variable. So I have to do the same thing for B, and I have to do the same thing for C. So I'm going to have another line for B, another line for C. I'm sure that makes sense. I'm basically just exhausting the domain. What does it look like? TBA or RBA or TAB or RAB and TBB or RBB or TBB or RBB and TCA or RCA or TAC. Oops, I'm sorry, that should have been B. Should have. This should be TCB or RBC, TBC or R. I'll get it, don't worry. CB or R. Okay, I could just look at this, right? Because I did flip them around. Okay, so the A should be the B. B, C. Is that right? Or R. C, B. Nope, that's wrong. That should stay. That should be changed. The A should be a B. And this should be the other way around. Okay. And, you see, you really want to do this kind of like methodically and carefully at checking your work. It is kind of like brute force strategy. It definitely does show you how you are exhausting the domain. RAC and what we have here, since we're getting rid of the y's, is going to be TBC or RBC or TCB or RCB and TCC or RCC or TCC or RCC. Boom. And now bunch all those up. And this is going to be the full expansion, this expression in this domain. So some things to observe, just like as a matter of symmetry, you'll have one of these. Wow, that's a weird sound. You'll have one of these expressions instantiated to A, that is TAA or RAA or TAA or RAA. And that was because that's an indication that the quantifiers are wide open, right? You also have TBB or RBB or TBB or RBB. Same deal, gonna have to instantiate it there to B as well, same with C. So you've got kind of a symmetry going on, or at least a pattern here. And you can look at this. So this has to be true for this disjunct, right? For this long conjunction, that is, this disjunction, this has to be true. This TAA or RAA has to be true. Same for TBB or RBB or TCC or RCC. For this whole expression to be true, right? We've expanded it. So you can check, just kind of eyeball and say, is it the case in our finite domain, or our interpretation, that TAA or RAA is true? Is A taller than itself? No. Is A related to itself? No. Okay. Well, look. This was a conjunction right here. Conjunction. The first conjunct is not true. So what does that mean for the whole expression? In our domain. Not true. Now, again, if you can just eyeball it like I did at the very beginning, you can avoid yourself some of those steps and troubles and faltering, trying to figure out or remember what variables are instantiated to what, just by observing. Quantifiers wide open. Keep running this chair. Quantifiers wide open. That means everything in the domain has to satisfy taller than, and it is not the case that everything in the domain does. So save yourself some trouble. Let's try what is hopefully an easier one to expand, because it doesn't have multiple quantifiers, just has an existential. So we've got, there is something such that R, X, Y. So in our domain, we're basically just trying to evaluate if something is related to something else. Now, again, you can save yourself some trouble and just observe that I didn't say anything about related then. I didn't make any assertions of fact about relations or using R. And we adopt the closed world assumption for our logic here, for first order logic, or L3 is the theory of L3, which is to say if you've not said something, then it's false. So it is false that anything is related to anything else. We've not said it is. But let's check just to see. This is a straightforward one. It's only really one step. So you have to pick everything in the domain, like one after the other in sequence. And so what do we have? It's RAA, RBB, or RCC. Is any of that true? No. We definitely need to permute RAC or RAB, true? No. Or RCA or RBA. Is that true? Any of those? Nope. You see what we're doing, right? RBC or RCB, true? We're just kind of mapping over all of the possible options that you might see that you're running through. None of them are going to be true, even though this is a disjunction, which is typically an expression that's weakly or rather easy to make true. We're not going to get anything like that here because it is in fact the case that nothing in our domain, in our little interpretation here, is related under R. So straightforward. Let's check out one that is slightly more complicated. Is it slightly more complicated? I guess it is. So let's check this out. It has two existential quantifiers. And this is about something being taller than something. Now, of course, it is the case. You're just looking at the facts. On the ground, something is taller than something. Like Alex is taller than Bob. Charles is taller than Bob, right? So that we could see that and just kind of eyeball it. Let's expand it. Step one. We'll get rid of that existential, and we'll say we're left with the expression T-A-Y. We're left with existential y T-B-Y, and then or existential y T-C-Y. Now, of course, we have to expand this again. Step 2. We want to get rid of that universal or that existential. So what we're going to do is we're going to say T-A-A, or we're just going to stick with one by one. We're starting here. We've got to expand T-A-A, or T-A-B, or T-A-C. This is just for that one. Now we're going to move over here, decompose this. We're going to see some redundancy, no doubt. We're going to get T-B-A, or T-B-B, or T-B-C, or maybe we won't get some redundancy. Let's check this out. One more decomposition. We're going to get T-C-A, or T-B-A. I'm sorry, this should be C. T-C-B, or T-C-C. Note some other observations worth making, just because I'm a stickler for symmetry. I'm going to get claims that Alex is taller than Alex, Bob is taller than Bob, Charles is taller than Charles. Of course, those are not true in our domain. Not true, not true, not true. Now this is a disjunction, so just one of these disjuncts has to be true. Of course, it's composed of disjunctions, so really if any of these assertions are true, the whole thing is true, this whole expression is true. So let's see, I said Alex is taller than Bob, Charles is taller than Bob, and that is correct. Let's look for those. They should better be here in our legend. Alex is taller than Bob, Charles is taller than Bob. Everything else, open world assumption, not true, not true, not true, not true, don't matter. We've got a riches sufficient to let us say this is true because we only needed something being taller than something to make it so. All right, let's check out another example from the homework. Same domain, same interpretation. This one I had, this was a fun one. We have, if Charles, say L, Charles is a lamp, and that Alex is taller than Charles, and if that is the case, what we're going to have is something is related to blah, blah, blah. I can already tell you because this is not true. We don't really have to do anything because the thing the arrow is pointing from is false. The whole expression is true. Yeah? So this is trivially true. Now I do want to show you a couple of things with this. So I'm going to replace this example slightly. I'm going to put a B here. Alex is taller than Bob. And this is true, right? The thing the arrow is pointing from is true, so there's not like a trivial truth we're going to point to. Now note I'm going beyond the homework here, so the homework answered with a C. That's true, it's trivially true, but what I'm going to do here is show you if this were true. Now we have to expand this bad boy and evaluate if it's true or not. Now I do want to highlight something for you with this expression. So note, and I'm going to just move that away because we don't need it because we're in the space over here and we don't need to do an expansion on there. But note that there is not any quantifier binding the y. There is a quantifier binding the x. That is correct. What happens here is when you see some like unbound quantifier, there is an implicit, an unbound variable. There's an implicit universal quantifier. If a variable is unbound, then it is implicitly bound by a universal quantifier. Now why? Why? Well, look, the variables, their interpretation is that they can be anything. Anything. And what is anything? Everything. Everything in the domain might enter into that variable. And so there is an implicit universal quantifier here. So this is essentially saying that for everything, something's related to it. Now, you and I know nothing's related to anything in the domain. Still, we're going to expand this bad boy out anyway, just for the sake of pedantry. I'm going to drop that universal quantifier off, and I have some x is related to a, or some, and I should say, because it's universal. Some x is related to b, and some x is related to c. Now, that's step one. Step two, for each of these, I'm going to have to expand them. So I'll start here with the first one. I'm going to drop that universal off, and I'm going to replace the x with an a, and then I'm going to put a disjunction because I'm getting rid of the existential, and I'm going to instantiate that x to a b, and then I'm going to go ahead and do that again for the c. Now, this is just expanding that first line. I'm going to need to put a conjunction here, you see, one there. Now I'm going to move to the next line, right here. I'm going to do the same, so I'm going to get r, drop that x off. I'm going to put here because I'm going to try to expand into the, or instantiate into the a, or ab, then r, bb, and then r, c, b. And now I'm going to move on to the last one here. I'm going to go r, AC, or R, what is it, C, C, that's not right, or BC, or RCC. So now I've gone through all of the options. Of course, there's symmetry to observe here, here, and here. Regardless, and none of these are true because nothing's related to anything else. And so even if I were to put, or as a matter of fact, if I did put LC, so Charles is a lamp, Alex is taller than Bob, which is true in this conditional. Say this is true, this is false, whole expression would be false. So again, we got that because this was C, like Alex being taller, or asserted to be taller than Charles, because that's false. This whole thing is trivially true. You can see if I were to modify it slightly based on truth, the truth conditions for material conditional, we'd end up getting a false expression. All right, let's keep going. Let's see. Should I do one that's more interesting? I think so. Let's check this bad boy out. So I've got not existential x existential y or x y. So nothing's related to anything. I've been saying that. That's what I've been saying. You know it, right? Like you've heard it. Nothing's related to anything. How do I expand this? I mean, you don't even need to. You just go look at the diagram and you're like, bro, nothing's related to anything. How would I draw a diagram about that? Easy peasy. Check it out. A, B, C. Nothing. That's it. Nothing else to do. Let's expand it anyway. You know, I'm a glutton for punishment, I suppose. But look, we don't know how to expand this, right? Like, how do you get rid of the negation? Like, how do you expand it? How do you say not about something in the domain? I don't know. Once you start mixing quantification and negations, things get tricky, things get wild. But I know a couple of facts about these relationships, and so I know, for example, that not something is equal to everything not. So if I say nothing is purple, then I mean for everything it's not purple. So if I say Alex is not purple, nothing's purple. If I say that is essentially me saying Alex is not purple, Charles is not purple, Bob's not purple. Like, so nothing's purple. So I could say of each of them. That's what's going on here. No x is the same as saying not for everything. So I'm going to use this fact to push the negations through. I'm going to do it in steps just so you can see it. What I do is I replace the existential quantifier with a universal, and that gets me not all x there's no y such that Rxy, that's the first step, but I can keep going. For all x, all y, nothing is related to everything, right? Let's check it out. Next, I'm going to replace this here, put that universal expression with the negation right there. And now I can do my expansion. I can drop off the quantifiers. I'm going to do it in steps as usual. Drop off the first quantifier, and that's going to give me not RA y, and universal quantifier not B y, and universal quantifier not C y. And this is going to lead us into our next step, because now I'm going to have to expand each of these into the domain. Now I'm going to start here. The first one, I'm going to do it line by line, not A, and not B, and not C. This is just the first side, right? Just expanded that first item. Going to move on to the next one right here, where B comes first, not RBA, and not RBB, and not RBC, and go on to the last one, not RCA, and not RCB, and not RCC. And that is the full expansion. Now, check it out. Is it true that A is not related to itself? Yeah. Is it true that B is not related to itself? Yeah. Is it true that C is not related to itself? Yeah. You really only need one, or really need to, check one, right? These are conjunctions. No, that's not true. Forgive me. I'm getting overzealous. Need to check them all because it's a conjunction, not a disjunction. So go through. But we already know, right? Nothing's related to itself in this domain. So it is in fact the case that all of these are going to be true. Boom, boom, boom. That expression is true. All right. Now let me do one more. This will kind of highlight some of the subtleties of moving negations around, because what we do have is for some x, it's not the case in Rxy. So I did get a little tricky with you, right? Like I was like pushing the negations through. Now if you use the trick I just showed you, this expression can replace that not y with a universal, and then just put the negation behind it. So effectively what this expression can be interpreted as is there's something such that it's not related to everything. Let's find out. So step one, expansion. Dropping off that existential, we have not a y, don't forget that universal, or universal y not b y, or universal y not c y. This is our first step. We'll move on to our second one. Boom. We're going to have this item here as our legend, and we're just going to drop off in each case that y are not the case that RAA. And because this is a universal, to be careful, we're going to add a conjunction here, not RAB and not RAC. And this is our first item here, you see. Now we're going to move on to our second. We're going to just go ahead and plug in again. We're going to start with B, A, and not R, B, B, and not R, B, C. Or I'm going to go back over here to C, not RCA, and not RCB, and not RCC. Okay, we'll see again. Of course, symmetry, always a fan of pointing it out. Boom, boom, boom. Unpacked all of our legend. We have basically a permutation over the space of finite individuals. Now let's check it out. Is it the case that any one of these disjunctions is true? Is it the case that A is not related to itself? Is it the case that A is not related to B? And is it the case that A is not related to C? Well, yeah, man. Yeah, absolutely. Right? Right? Because nothing's related to A. Yeah. So we just needed one disjunct for this to be true. So this expression is true. It's a little more interesting because we're playing with the related then. You can see it's probably implicit that I was, making. I wanted to highlight some of the triviality here, but also make it so that you hopefully see the form, what I was getting at here. I'm saying that nothing is taller than anything, right? We do our little trick. For everything, it's not taller than everything else. So here's what we're going to do. We're going to step 1, drop off that first quantifier. So not a y, all y, not a y, and then conjunction, all y, not t b y, and for all y, not t c y. And this is our first step. It'll give us our legend, which we can unpack. We'll start here. Our first conjunct, we're going to drop that off T-A-A and not T-A-B and not T-A-C, all bound up into a big conjunction. We're going to move over here to our second, same drill. We're going to go not T-B-A and not T-B-B and not T-B-C. Conjunction again, move on. Not TCA and not TCB and not TCC. Now, check it out. We got that symmetry I'm always talking about. Boom, boom, boom. Now, this is a conjunction. I'm talking about everything. It's a big conjunction because it's a universal scope. Is it the case that Alex is not taller than Alex? Yes. Is it the case that Bob's not taller than Bob? Yep. So these are true. Good. True. Remember, everything has to be the case, or has to be true. So is it the case that Alex is not taller than Bob? No, Alex is in fact taller than Bob. Whole expression is false. We just needed one. It's conjunction, big conjunction, everything bound up there. So let's see, should I do another one? Is there anything else tricky? So I feel like I've covered like the scope of the possible tricky examples here. So basically gave you some tips, a detailed ad nauseum characterization of expansion in the domain. There is the other example with next to, and what is it? Charles and Bob being next to one another. I think for the most part, you're going to see similar expansions. Nothing too surprising. The boys and girls example, you're going to see a lot of that same thing. So no tricks there. So the resources I've given you here so far should be more than sufficient to be able to expand those other problems. And so I won't go through them here. I'll just leave you to that enjoyable exercise on your own, or if you prefer to draw the diagrams, it's probably the faster thing to do. So with that, if you have any questions, comments, concerns, compliments, let me know. I'll be closing. See you soon.